right, guys. So for today, we're going to do the second learning target, which is absolute value of the inequalities. These aren't so bad because we don't really have to check as much. Yeah, right? Like that makes it that much easier. All right, I'm going to kind of strain your brain back to some Algebra 1 stuff here. We actually talked about it a little bit when we did that card sort with the different graphs. Remember we talked about open and closed circle real briefly? Boys, are we okay back there? All right, so taking you back to Algebra 1, the less than and greater than, when we graph those, it's going to be an open circle because that number's not included. If it has the or equal to, we're going to color it in to symbolize that number is included in our answers. Okay? So the thing what we're going to have to do is we're still going to be solving the absolute value. So I have 2 bars. I'm still going to have 2 equations or 2 inequalities with 2 answers, not 3. 2 answers. All right, so when we're writing these 2 equations, they're either going to be and or statements. So if your original problem is a less than, do you guys know that this one is less than? It looks kind of like an L that got squished. L for less than, if you're not sure. Yeah, see, look at that, right there. That's Pac-Man. I hate that people teach alligators. Come on now. Look. It's Pac-Man. Way easier. Sorry. Anyway. So if it's a less than symbol, when you write your 2 equations, it's going to be an and statement. Right? If it's a greater or greater than, it's an or statement. See, huh? See how I did that? Helps me remember which one's which. All right, because I expect to see the words and or written when you write your 2 inequalities. Okay? So the whole and or thing, to try to help you out a little bit. If your mom, you get home from school today and she says, you can have a glass of milk and a cookie. What do you get? You get both, right? I get a glass of milk and I get a cookie. I get both. But if she says you can have a glass of milk or a cookie, that's mean for one. But what do you get? One or the other. All right, guys, just work with me here. I'm trying to get you to visualize this so that you can understand. All right, so the or statement means I can have it one or the other. I cannot satisfy both of them at the same time without getting in trouble, your mom yelling at you, right? The and statement is both. So we're writing 2 inequalities. If it's an and statement, the numbers that are my answers will work in both inequalities. It fits both of them. If it's an or statement, if I asked you pick a number that works in that inequality, it would be one or the other inequality. I could never pick a number that works in both. It's kind of like think of cookies and milk. Okay? All right, so here we go. So if I have the absolute value of x is less than 5, I want you to solve and I want you to graph. So just like yesterday, I see 2 bars, I think 2 equations, right? Same idea as yesterday. Now yesterday when we did this, if that was an equal sign, you would have told me x equals 5 and x equals -5. Same idea, but I don't have an equal sign. So it's kind of like a double switch. I not only will switch that 5 to negative, I'm also going to flip this sign to a greater than. I'm going to flip it to its other way. So here we go. So I'm going to write x is less than 5. Again, just like yesterday, the first thing I write doesn't change. And if it's a less than, that's an and statement. And x greater than -5. Right? We're going to switch the inequality and switch that number to a negative. I'm going to do both. Okay? Now when I graph this, okay, when you're graphing, I don't care, to be honest with you, I really don't care what you count by. 0 doesn't have to be on your number line. In this case, it will because that's where my numbers fell. But like if your numbers are like 3 and 10, 0 doesn't have to be on there, okay? So on this one, I'm going to have to go from -5 all the way to 5. What's probably the easiest way to count this? You could. I'm going to count by 5s. I'm going to count by 5s. A little easier there. When you're graphing, my only requirement on the graphs is you must have at least 3 numbers on your graph. Well, now in this case it worked because it was like -5, 0, 5. I counted by fives. But could I have like -3, 0, 25? No, I can't do that. When you're doing graphs of any type, when you're graphing like an XY axis, all that stuff, you have to be consistent. If I'm going to count by fives, I count by fives the whole way through. If I'm going to count by twos, I count by twos. I can't go -3, 0, 25. It doesn't make any sense, okay? So you have to be consistent when you're counting. I like when the numbers are like opposites like that, though, because then I can make it real easy. All right, on this problem, would they be open circles or closed? They're going to be open, right, because there's no line under them. So I have an open circle at both. Oh, yeah, that's fine. Yep, totally fine. And then we're going to graph this. You may or may not remember doing this from Algebra 1. But where are the numbers less than 5? To the left or to the right? To the left, right? I always draw mine above so I can see it. And where are the numbers greater than -5? To the right. So these actually connect in the middle if I could draw a straight line. So in other words, what you're doing by graphing it is you are showing me where all the numbers are that are the answers. So everything between -5 and 5, somebody pick a number in between there. I heard 2, I heard 3. What's the absolute value of 2? Is 2 less than 5? Yeah. Somebody said 3. Absolute value of 3 is 3. Is 3 less than 5? Yeah. So anything I pick in between here satisfies it. And does it satisfy one or the other of these equations or both of them? Both. Because it's an and statement. Cookies and milk. It should satisfy both of the inequalities. And it does. Any number I pick in between here, like you said 2, 2 is less than 5. 2 is greater than -5. It fits in both. Okay? All right, on the next one, absolute value of x is greater than 5, just so you can kind of see the difference between the two of them. So again, just like we started yesterday, absolute value, 2 bars, 2 equations. So I'm going to write x is greater than 5. I don't change what's in jail. Everything just the way I see it. Is this an and or an or? It's a greater than, so it's an or statement. Or x is less than -5. I mean, right away you can look at that. If I asked you to pick a number greater than 5 and less than -5, you'd be like, what? Like you can't satisfy both of those, right? There's no number that's greater than 5 but less than a negative number. It's not possible. So that's why it's an or statement. There's no way you could ever pick a number that satisfies both. All right, if I go ahead and graph this, again, I have to have -5 to 5. I should count by 5s. Ta-da, I got my 3 numbers that are my minimum requirement there. Open or closed circles. These are open. All right, where are the numbers greater than 5? Right or left? To the right. Where are the numbers less than -5? So look at your graph. Your graph is pointing to all the numbers that work. See how it's going in opposite directions? All right, but if I look, I could pick any number in here, right? A number greater than 5. 6. Absolute value of 6 is 6. And 6 greater than 5? Yeah. What number is less than -5? -13. What's the absolute value of -13? 13. Is 13 greater than 5? Yeah. So you're showing me all the numbers that work. It's not like we solved yesterday with equations where it was like x equals 5, right? It's not that simple because we're talking about less than and greater than. So you have a whole range of numbers. So your graphs are showing me where those range of numbers are falling. Questions so far? Do you remember some of this from, or at least this basic graphing stuff from Algebra 1? Is that coming back a little bit, Alex? Okay. All right, solve and graph. So again, I'm seeing this absolute value, right? 2 bars. So the first thing I have to do is write 2 equations, 2 inequalities. So we're going to have 3x is less than 18, and or. And 3x is greater than -18. Good. There's the hardest part. Whew, right on my 2 inequalities. So from there, we just need to solve. divide by 3. So x is less than 6, and divide by 3. X is greater than negative 6. And then we have to graph. So again, I worked out a nice one where my numbers are easy to work with here. I have to go from negative 6 to 6. What do you want to count by? You can count by 3s. I'm going to count by 6s. I'm lazy, remember? Open or closed? Open. All right, go back and read your inequalities. Where are the numbers less than 6? To the left. Where are the numbers greater than negative 6? To the right. So they connect. Yes? As long as your variable is listed first. Yes, you're right. What she just said, if you look at this, as long as your variable is listed first, what she said is accurate. This is pointing to the way your line should go. Right? From 6, it's pointing that way. That's where we drew the line. The only time I caution you is when you would get something that looks like this. And that happens quite often. So just, it has to be listed first for that to work, that trick. All right. How about that one? Is your absolute value by itself? Yeah, there's nothing with my bars. All right, so 2 equations are my 2 inequalities. Do I ever mess with what's in jail? Nope. Is this an and or an or? And. Less than is an and. X plus 5 is greater than or equal to negative 9. Good. And then we just need to solve. So we'll subtract 5. So x is less than or equal to 4. And subtract 5. X is greater than or equal to, good, negative 14. Ooh, when I'm graphing, I have to go from negative 14 to 4. Is 14 a multiple of 4? I'd probably go by 2, yeah. So there's negative 12, negative 10, negative 8. My marker write's too fat to fit all the numbers in there. Negative 6, negative 4, negative 2, 0, 2, 4. I may not have written all my numbers because my marker write's too fat to fit them all in there. But I have every tally mark that should be there when I'm counting by 2s. Does that make sense? If I try to write them all with my marker, it'd look like a big old mess up there. No. Open or closed? Closed. So I have a closed at 4 and a closed at negative 14. As long as I can tell that you meant for it to be closed. All right, so where are the numbers less than 4? Left. And the numbers greater than negative 14? To the right. Yep, it's got the equal to part underneath it. That means I have to color it in. Because what that means is that number that it's on is actually an answer. So like negative 14 is colored, that means I can use this. Negative 14 plus 5. Anybody? Bueller? That would give you negative 9. What's the absolute value of negative 9? 9. Is 9 less than or equal to 9? Yes. So before, when the open circles, this is not included. Because if I try it here, 3 times negative 6 is negative 18. Absolute value is 18. Is 18 less than 18? No. So the open circle says this answer is not included. I can get really close. Like I can go negative 5.999999999. I'm really close. And that would work. But that one doesn't. Okay. You guys okay if I skip this one? Can I skip this one too? I do want to look at some that are a little harder, though. Sorry. They were the really easy ones like we just did. So I want to look at some that are a little harder. All right, so on something like this first one, it's not isolated. Divide by -2. So I have the absolute value of x plus 4. Any Algebra 1 sirens going off right now? It's not no solution since it's not an equal sign. If that was an equal sign, you'd be right. That would be a no solution because it's negative. However, what's going on right there? What happens when you divide by a negative with inequalities? Yes. Your inequality switches. If you divide by a negative, your less than switches to a greater than. Sure, you want to flip an equal sign? If I flip an equal sign, it still looks... Yes. Sorry, I was being funny. But yeah, any less than or equal to, greater than or equal to, those rules apply. Okay, so be very careful. If you divide by a negative, it flips that sign. What happens if you multiply by a negative? It flips the sign too. Dividing and multiplying, they go hand in hand. But adding and subtracting doesn't affect it at all. So if you don't remember that, make yourself a note. If you multiply or divide by a negative, your inequality switches. Okay, so there's a nice example. I divided by a negative, so it switched. It was less than, it flipped to a greater than. All right, once it's isolated, now I write my two equations, right? So what's the first one going to be? You went a step further than I wanted. So x plus 4 is greater than -11. And or? It's an or. I've switched it. Yeah, it goes off of what you just did, and that's an or. And then x plus 4 is, what do I write? My second equation, what happens over here? Less than 11. Yeah, that greater than will flip to a less than, and the -11 now becomes 11. It switches to its opposite. So yeah, that sign is flip-flopped quite a few times in this problem. All right, so if we go to solve, so x is greater than -15, or x is less than 7. Correct. Yep. Just to reiterate what Alex just said, the and or, that comes from after it's isolated. So I isolated it, then I'm looking, that determines my sign from there. All right, so if I'm graphing this, I need to go from -15 to 7. Seven's not a multiple of 3. Can I count by twos? Odds? You guys ever hear that you guys know who Bob and Tom is? Morning radio show. Do you ever hear the song, the 18 Wheels on a Big Rig? No. If we get a chance to end the class today, I'll play it. I'll see if I can find it online and play it for you guys. But it's so funny. It's like talking about the wheels on a big rig. There's 18 wheels, right, on a semi. So it's like counting, like, 1, 2, 3, 4. He counts all the way to 18. It's fine. He's like, let's do evens. He's like 2, 4, 6, 8. He's doing fine. He's like, let's do odds. He's like 3, 6, 9. No, he goes, I missed my odds up. 1, 3, 5, 7, 9. Like it took him, and then he slowed way down because he couldn't count by twos with the odd numbers. It's kind of funny. You have to hear it. I'll play it. You guys are looking at me like I'm crazy. I'll play it. It's funny. Because then they count by Roman numerals, and then that's really funny. Yeah. I'll find it. I'll play it for you. It's funny. All right, so that'll be -13, -11, -9, -7, -5, -3. I didn't leave enough space. I'm usually really good at guessing how long my line should be. It was off. -1, 1, 3, 5, 7. There we go. We counted by twos, but with the odd numbers. I got to play that for you. It's funny. You better laugh because I think it's really funny. Okay. All right, open or close circles? Open. Where are the numbers greater than -15? Left or right? They're to the right, and less than 7 are to the left. So it goes like that. What? It's not all real numbers. Because anything less than -15 doesn't work. Anything greater than 7 doesn't work. So only the numbers that work in here are just the numbers in between here. What? Oh, you're right. What just happened? Hold on. No, you're right, because it's an or statement, so it should be one or the other, not both. Yeah, that's not what my inequality says, though. You're right. He's right. He's right. This should be all real numbers. Thank you. I totally missed that. Since it's an or statement, these don't happen very often. Kudos for you catching that. Since it's an or statement, it should fit one or the other, right? So I could pick a number greater than -15, any number greater than -15. This is my number line extending, if you didn't know what I was doing. Or I could pick any number less than 7, so anything back here either. So really, it's all real. Good catch. That's what happens when you are like, oh, I need to make sure this type of problem gets on there, and then you just jot a random problem down. That's what happens. But good catch. Kudos. All right, how about the last one over there? That's not problem 13. That's 13 minus 9 times the absolute. Not problem 13. So what do you do first? Do I do 13 minus 9? Do I divide by 9? I take away the 13. Yes. Yeah, on this one. Yeah, we need to subtract the 13. I think we had conversations about this yesterday with that one problem that's straight back there on the board. So we have -9, absolute value, 4x plus 11, is greater than -9. Then what? Divide by -9. So 4x plus 11 is less than, very nice. That greater than switches, why? Divided by negative. And that gives me 1. Who says you caught the all real number there. All right, so that gives me 1. All right, so we have 2 bars, 2 equations. So 4x plus 11 is less than 1, greater, or I'm sorry, and or. And 4x plus 11 is greater than -1. I can extend my board down, but I haven't yet learned how to extend it that way when I run out of space. This extends it down. Yeah. No, that gives me more options. I know. Okay. I can do that, though. That's cool. All right. Yeah, moving my smartboard doesn't help either. That doesn't work. All right, so we need to solve. So we'll have 4x is less than, it gives me -10. So x is less than -5/2. Do I switch the sign here? From here to here when I divide, do I switch it? No. I have students every year who want to because they see the negative, but what did you divide by? A +4. So I didn't divide by a negative, so it doesn't switch. And so we'll have 4x is greater than negative 12. So x is greater than negative 3. Okay. Ooh. Let's talk about this real quick, because when fractions show up, people freak out on me. Okay? You have some different options how you want to count this. I really don't care. I'm not overly particular about it. Where is negative 5 halves? That's negative, try again. Negative 2 1/2, thank you. That's negative 2 1/2. Guys, when it comes to fractions, because some of them would be like a third or something like that on there, kind of crazy. I don't expect your fractions to be perfectly on your number line. You can estimate where they're at. So this is really like negative 2 1/2. So really I need negative 3 on there, and I need negative 2 on there. I need at least 3 numbers, so I'll throw a negative 1 on there. Right? Because this is negative 2 1/2. So really that's right in here. And then negative 3. This is a fun graph. The numbers less than negative 2 1/2 and greater than 3 is right there. It's like a little musical note or some cherries. Musical note, if you're a musician at all. All right. So don't forget, if you divide by negative, that sign flips. Okay. That crazy one right there that I threw on there, that doesn't always happen where it was all real numbers, but good catch.